So thank you very much for this opportunity. I must, thank my old friend and colleague, Professor Shomnath Bharadwaj. We have been student way back in early 90s in Bangalore, and I think these are opportunities to celebrate our history, our legacy, and so on. So today, although as has been mentioned, that my subject area is solar physics. But I'm going to talk about my parent institution, my current institution, where I am now. And just to give you an overview on the activities currently at this Aryabhatta Institute. But before I go there, I think we have to always, remember the history. And since this kind of platform is ideal for letting people know in the country that we have come long way, and for the Azadi Ki Amrit Mahotsav celebration, we always need to find out where we came from and how these kind of small institutes came up, and eventually government supported these institutes to the current level is really need to be appreciated and congratulated. So, I will provide a historical perspective first. I probably will not go into technical details of any of the astrophysics or atmospheric sciences research which is currently undertaken here. But if there are questions, I will be happy to answer, and then probably it sets the platform for further communications post the seminars as well. So the historical perspective, Dr. Sampurnanand, who encouraged astronomical sciences, it started with his, role when he was the Minister of Education in 1951, and then later he became the Chief Minister of Uttar Pradesh, and Aryabhatta Institute came into existence as UP State Observatory. So that time it was UP State Observatory, and then Professor and eminent mathematician Dr. A.N. Singh was the convener of the committee. So he recommended to set up an observatory at Varanasi to start with, and to plan to develop a full-fledged observatory at appropriate location. So UP's SO came into existence at Varanasi in 1954, and Dr. Singh acted as honorary director. So it all started from Varanasi. But then Dr. Vainu Bappu, who was the sort of former director of Aryabhatta Institute, and he's also considered as to be our godfather of astronomical research, modern astronomical research in India, because after coming into back into the country, he took charge of Aryabhatta Institute, and parallelly he took charge of Indian Institute of Astrophysics also at Kodaikanal. So you will see that in India the observational astronomical sciences largely are indebted to Dr. Vainu Bappu, who unfortunately didn't live very long, but he really paved the way for modern astronomy in India. So finally, Nainital was selected as most appropriate site, and UPSO was shifted from Varanasi to Nainital in 1955. I will show you some historical pictures. And Dr. Sanwal was a long director from 1960 to 1982, and he supported major observational and facilities at this location. Dr. Pandey was also back from Russia, and then he was the next director. He worked on, theoretical aspects of sun spectroscopy. He predicted the molecular species presence in the solar atmosphere. He established the solar telescope and also set up a horizontal spectrograph, including a celostat kind of arrangement here to do spectroscopy on the solar atmosphere. He augmented support facilities and instrumentation for solar and stellar work. Then there was a big change. Professor Ramsagar, he moved from Indian Institute of Astrophysics, took up the directorship of the State Observatory. But then there was a major change when the state of Uttarakhand was born. Then it was rechristened as Aryabhatta Institute under DST, Government of India. And once we became a autonomous institute under Department of Science and Technology, Government of India, it took major initiatives. And now currently we host the largest optical and infrared telescopes in the country, along with the liquid mirror telescope, which has got its first light just a few weeks back. So these are some of the historical pictures of Varanasi in 1954, and as I pointed out, it got shifted to a room in Devi Lodge in the Nainital city in 1955. Then people were looking for opportunities in this region. They identified this particular peak. It's called Manora Peak. We are about 9 kilometers away from the Nainital town. And this was the historical picture, which you will see more modern pictures there. So the first telescope was a 25 centimeter refractor, which was first at the Devi Lodge, as I mentioned. And then once the Manora Peak was identified, it was moved to Manora Peak. Incidentally, you know, in the older days, astronomy was done only with photography, and then initially the plates, and then it was films and so on. But the first electric photometer was installed in 1956. So way back, you know, in an early independent India, we already started looking at modernization of astronomical observation, and this was, you know, much before the, you know, the modern day cameras in form of digital cameras, you know, all CCDs and so on, were all initiated here way back. This was again a sort of major change. Way back in 1958, these are called Bacon satellite tracking camera. This was installed here. It was a sort of, you know, 51 centimeter big lens. Incidentally, this particular telescope was non-operational for many years, and now very recently, with the collaboration of ISRO, we are reviving this. So I thought, you know, it would be really worthwhile to also mention to this kind of forum that since we are, you know, celebrating Indian heritage and the sciences, what we did last 50 years, it is important to revive and maintain some of these legacy instruments and see how we can modernize them and use it for maybe training purpose, may not be for the cutting edge science, but it is important to maintain those legacy instruments and make use of it. So I thought, you know, I will mention about this particular telescope. Such, you know, old telescope being operational is almost rare in the entire world, and we are, you know, we are able to do this. So for about 2 decades since 1958, the observatory was the only center in India for optical tracking of man-made Earth satellites. So this was, of course, a US supported program. There were a lot of transits which were recorded. First photograph was recorded on 29th August 1958. So you see the historical time scales of this. And because of all this tracking and all that, the accuracy of the Nainital, you know, our peak and so on and so forth was order of 10 meters on the world datum as well. So now I jump a little bit onto the modern day, what we do. So as I mentioned, since 2004, we are an autonomous institute under DST, Government of India. Our mandate is to promote, guide, and carry out frontline basic research in the areas of astronomy, astrophysics, and atmospheric sciences. So I will also mention that Manora Peak, since this is part of the Himalayan, you know, ranges, a lot of very good atmospheric science research can be done from this, you know, particular platform. A lot of comparisons can be done in terms of the pollution and the low Earth atmospheric modeling into these kind of Himalayan altitudes of 2000 meters as compared to the plains we have set up in Haldwani, which is in the foothill, also similar instruments, and then comparing the different, you know, atmospheric parameters, the pollutions, and so on. So this is a new branch, I would say, has emerged after this institute was taken over by DST. We also build and operate state-of-the-art facilities to study Earth's atmosphere, planets, stars, galaxies, and other celestial objects and phenomena. So as I mentioned, you will see from my presentation, the most modern instruments and the facilities are at this site and our new site, which I will come to next. We have made several important contributions in the field of discovery of rings of Uranus and Neptune, detection of first microlensing, and GRB even from Indian telescope. I will mention about one telescope which was installed here in early 70s, a 1 meter telescope. I will show you more pictures of that. It was named under Sampurnanand, and that telescope is still completely functional, and it produces PhD quality, research output. So I don't think in many part of the globe, a telescope which is as old as 50 years now is still fully functional. So of course this was a Carl Zeiss German make telescope. One telescope was brought here in India and was placed in Manora Peak, Nainital. The other one is actually still there at Kavalur, but it's not as functional as this one here. So we operate India's largest optical telescope at Devasthal, which is at 2.5 kilometer altitude, about 50 kilometers from this campus at Nainital, where I'm giving the lecture from. And we also host the India's highest altitude Aerosol observatory and the ST radar facility at Manora Peak, which is at an altitude of 2 kilometers. So these are two major facilities which we are running here. These are the two campuses. The top panel shows the Manora Peak, where I am in this little ellipsoid inside this. And then we have a new campus, which is called Devasthal. And again, I will sort of probably demonstrate. This is called BHARAT TIRTHA platform. And this is our Tirtha Sthan, so to say, where you will see that how well you can dedicate to your own research work as well. A close-up of this Manora Peak campus. As I mentioned, this is a historical, old campus. We have the main building, my office space, then all the PhD students. There are about 55 PhD students in campus. They all live in campus. We have the old 40-inch telescope dome. This is the 1 meter Sampurnanand telescope, which I was referring to. We have atmospheric labs. We have this big telescope, Bikanan, what I was referring to, which we are reviving again. And then there are new laboratories which has come up in terms of optics facilities, because we, as I mentioned, we are also developing back-end instruments for modern telescopes. Namely, the 3.6 meter telescope has a spectrograph in the back end, and we have done this assembly and testing in this optics lab. Of course, we have a science center as well at this campus with a small little planetarium. Public outreach is a very, very important aspect of the institute, and I will probably give you some examples of that. So this is the one of the oldest telescope which is fully functional. I mean, today is this 104 centimeter or 1 meter Sampurnanand telescope, and it has made lots of contributions. Even today, it does. It has polarization instruments in the back end, along with the modern day CCD cameras. And since 1972, it has been fully functional. And as I said, we will be celebrating actually 50 years of this by a big national meeting in the month of October as well. We also do solar observation from this campus. We have a 15 centimeter solar telescope with a H-alpha filter. So this H-alpha filter basically looks at the chromospheric heights of the solar atmosphere. In the solar atmosphere, about 1,000 kilometers and above, if you go, then you see lots of dynamic events happening. There are huge explosions happen, which can make impacts to our solar terrestrial environment, including our space weather environment. So these are called solar flares, and we do monitor these flares from this telescope, which is a modest 15 centimeter telescope. This is now, I'm taking you to the Devasthal Observatory, which is, as I mentioned, is at 2.5 kilometer altitude, about 50 kilometer distance away from here. It takes only a couple of hours drive to reach there. So this hosts the largest optical telescope from this part of the globe. We also installed a 1.3 meter optical telescope way back, more than 10 years. That time it was sort of, characterizing the site and setting up facilities of the observatory and all that. And then more recently, we have, have this 4 meter liquid mirror telescope. This is a very interesting concept. Rather than, either a solid mirror in the form of a glass or a lens. Normally, the lenses are not, found in big telescopes. These days, it's all reflector in the form of mirrors. But instead of a mirror, if you use mercury, and you pour this mercury in a very big bowl, and if you can rotate this bowl at a specific angular velocity, then you will see that the mercury will spread over across this paraboloid bowl, and then that will make a perfect reflecting surface. So this is the primary mirror with a 4-meter diameter at a much less cost as compared to a huge, glass material. So, of course, there are certain disadvantages of this liquid mirror telescope, because you cannot maneuver the telescope anywhere in the sky. You cannot tilt it, because the moment you tilt it, you can imagine that the mercury will have a differential, gravity acting on different points, and that will disturb the reflecting surface. So we keep this ball always pointed towards the zenith, and it has a half a degree field of view. Any object which comes within this field of view, any transient, any star or a planet or a galaxy or a satellite or a space debris, that is captured. And with very sophisticated modern imaging techniques and image processing techniques in terms of artificial intelligence and machine learning, we identify those objects and then try to characterize the properties of the object. The other very interesting aspect is why we have set up this particular liquid mirror telescope at the same side, is that suppose you discover or identify certain object for the first time in the sky, then immediately you can send a note, and the 3.6 meter optical telescope, which has a very sophisticated back-end instrument in terms of its spectral capabilities, infrared spectroscopy, and so on, it will be able to characterize the properties of that discovered object in the same night almost. So this is a big advantage of having two large size telescope at the same site with complementary capabilities. As I mentioned before, this 3.6 meter telescope, which was inaugurated by none other than our Honorable Prime Minister Sri Narendra Modi ji in 2016, we had this 1.3 meter Devassal optical telescope, and it's a modest DFM telescope, and you could see the beautiful Himalayan range in your background, and that's our TIRTHA sthan, as I mentioned, to to do your work or dedicated whatever prayer you can have. This is a close-up of this 4-meter liquid mirror telescope, as I was mentioning. So this will be used for survey of distant quasars, supernovae, because this is a large optical telescope. So you will be able to go much deeper in the sky as compared to other 2-meter class telescope which are there in other parts of India. So this we hope will lead us to major discoveries. This is again a close-up of the 3.6 meter telescope. This is almost like a 5-story building you can see here, and this is the telescope from inside the dome. And a typical man should be of this kind of height. So you can imagine how big and how mammoth this structure is. And this mammoth structure can be pointed to any object in the sky, and then it has an accuracy of tracking that object with very high precision and so on. So these are very modern telescope. This telescope was built in Belgium by a company called Amos, and the rest of the of course the building and other infrastructure and the back-end instruments, a lot was done in India. So there are instruments which has come from collaborations from TIFR, Bombay. So these are, really sophisticated infrared spectrograph, imagers. We have built a optical spectrograph at Nainital itself by assembling the parts taken from different parts of the globe, of course. So that's about our, part of the astronomy facilities in the at these two campuses. As I mentioned, that we have atmospheric science division. We look at air pollution and climate change studies. As you know that this is a high priority global requirement in terms of climate changes, and no place better than Himalayas to study them. So we have trace gases, aerosols, meteorology, dynamics, and so on. So there are different modeling and satellite data analysis center as well here. We are also participating in international field campaign like GVAX and SUSCAT. So a lot of Japanese collaborations are also there for these global, climate modeling efforts as well. As I mentioned already, there are several instruments for aerosol measurements. We do monitor the black carbon, the aerosol number concentrations, TSPMs. We have trace gas, chemistry labs here. We look at ozone, carbon monoxide, methane, and NMHCS also. And the greenhouse gases as well are measured regularly from this site and other sites as well. We are setting up actually similar labs in Devasthal as well, so that these kind of comparisons can be done at different altitudes and different topological circumstances there, because there are certain topological differences between the Manora Peak campus as compared to Devasthal site and so on. We have, as I mentioned, two major facilities in terms of the stratosphere, troposphere radar, which models the density as we go from low height to the up to 20 to 25 kilometer height, how these density profile changes under different conditions, different seasons, different cloud conditions, cloud modeling, and so on. Similarly, the LIDAR is using the laser as a probe. We use these kind of models. So a comparison between these different kind of facilities. Also, we do balloon flight once a week. So the models when the balloon flight are compared with the LIDAR, results to get a better accuracies and so on. So this lab, as I mentioned, have you could see here different probes. We do aerosol optical depth, black carbon. So this is a somewhat repetitions of what I've already mentioned, but I'm just giving you a collage of instruments and this balloon experiment which is done through the ozone sonde and radio sonde, which also helps in our density modeling and so on. Last 5 minutes or so, I will also try to highlight the importance of reaching out to public of what we do. I must point out that some of our kind of research institutions, we were mostly, doing our work, sitting at isolated corners and so on, and the common public at large or youngsters were not fully aware of what we do. So to some extent, it is our responsibility to reach out. So this is called the outreach program. And I must point out that even during the pandemic, we have tried to keep up to our outreach activities and have participated in different lecture series. We have done eclipse, observations from here, and we have done live casting of those. So these are some of the very recent one. I'm just saying we had it in a hybrid mode. We could, accommodate a fair good number of students in campus, and we had almost full day, activity in the National Science Day. We just heard about Raman effect, which we celebrate through this National Science Day as well. So there were multiple online and offline competitions for students, and a large number of people participated. We also go to other locations within our state and beyond. There were camps in Haridwar for Vigyan Sarvatra Pujyate. This was again part of our 75 years of Amrit Mahotsav, and we are actively participating in this. Outreach week-long Azad Ki Amrit Mahotsav celebration was done during 2nd to 6th August. Lunar occultation of Mars was done here, International Day of Light, World Environment Day, National Engineers Day, World Space Week, International Women's Day, and outreach through the website and social media. Of course, as you see, we have tried to really cope up with the modern platforms in terms of different social media and websites and so on. I will again show you examples of our participation in some of the recent exhibition we have not been able to do in the past, but after the pandemic we have started. And I will just draw your attention to the youngest person through looking at the facilities or the features of a telescope. She was an 80-year-old lady, but the enthusiasm she had to know how a telescope works and what a telescope can give you of a distant object coming closer to you was demonstrated to this lady. So my point is that I think we need such platforms where we could reach out to age groups from from young to old. It really doesn't matter the age. It's enthusiasm, it's excitement. What some of us feel through our career has to be shared with the public at large. Then only we can attract larger, bright students also into our research programs, and also support from the public and the government as well. So I think these kind of events are very important. So since I'm just giving an overview of our activities from the Aryabhatta Institute, just thought I will share with you that our commitment to the nation in terms of these programs as well. There is another very important element which I have taken up personally about the scientific data. We do research, we do generate lots of data, but often this data is not fully utilized. Why I say not fully utilized is because the data is only restricted to few individuals who have taken the data and have done some work, and then somehow the data goes down in somewhere through some cupboard and so on. It's never reaching out to others. So this is, I think, a bigger responsibility for scientists now at large, and astronomy does provide a good platform because we have the possibility of archiving our data, which has been taken over centuries actually. Today I am in Aryabhatta Research Institute, but I would just briefly on the passing mention Kodaikanal Solar Observatory has been there for more than 100 years. And we have digitized the data which has been collected from 1904 from Kodaikanal Observatory. Of course, famous discoveries were made from Kodaikanal Observatory by Britishers, famous British scientists like Evershed and so on. But these data were all lying in photographic plates and films and so on. And personally, I have taken the full responsibility of archiving that data, and that data is completely public now to the global community. And you won't believe it, the last 5 years or so, it has produced many more papers as compared to probably in the past. And I hope that in next 10-15 years also, it will be really the best archive in the world, because we have the data for more than 100 years. Not many people in the globe has such resources. So to me, again, I am taking up this particular subject or concept into this forum because I think this is a very important element in terms of how the scientific data is made available to the larger community and also the students who are not still into the hardcore research. Often what happens is the data, the way we store is only understandable to very few individuals. So it is a responsibility for all of us to make that data in a more user-friendly way with much more documentation and uniform formats and so on and so forth, so that the students who are interested into research, they can look at the historical data and establish. You see, sometimes I feel when we get into a research, first you should confirm what is already published or what already is very well known. Once you know that you can establish, that's how physics moves, as with the experimental verifications of known theories, right? We all do, experimental verifications of Ohm's law to start with in our high school. So similarly, if our data and some of the smaller, output which has come from those data if these students can, play around with that, then they can be motivated, and then they can be exposed to, much larger data products. So this is something which we have taken up, and we hope within a year we will have the complete data archival available. I'm taking up that this 50 centimeter, the 1 meter telescope celebration day. I will launch the 1 meter, data archive, whatever best we could do with all documentations and so on. So as I mentioned, the homogeneity and complete information of the data is quite a challenging task, but it is the need of the hour. So we have plenty of data available from historical times. So it is important to bring that up. And as I mentioned, we have astronomy data portal, we have solar data portal. I've been able to actually, complete the solar data portal first because that's my expertise, and the atmospheric data portal also will be ready ready soon. So these are very important exercise in terms of our nation's growth. I will briefly mention that again, some of these institutions which have a long legacy, but we also need to work as a nation together. So, and modern day astronomy particularly is not restricted to ground-based telescopes alone, because from the ground-based telescopes you can only observe certain part of the electromagnetic spectrum, namely the visible and the infrared from telescopes. You can have radio telescopes, of course, which we have within the country, but we are privileged to have ISRO. And ISRO is launching many science satellites now. AstroSat is a major facility which is running more than 5 years. We're going to launch Aditya L1. This is a solar mission in January next year. And I'm part of the science working group of this Aditya mission. And what we have set up at Aries is the Aditya L1 support cell. That means, the training program, regular workshops, how to use solar data, how to apply for, solar data observational time, how to write a proposal. So these are, again, exercises which people from universities, people from smaller colleges, they are not aware of. They can't do this thing because they're not familiar with this system. So we have taken up that responsibility, of course, thanks to ISRO's complete support for that. And we are hosting our first workshop actually on 27th of this month for a group of students master students from different parts of the country. So my point is that it's very important to engage with this kind of larger training program. So again, I'm just in this particular forum, I'm taking this opportunity to give you a glimpse of what this UP State Observatory was originated from, from a state, support, but then it matured into a national facility, and of course, under Department of Science and Technology, it really, expanded to a larger facility, and then to the, expanding its scope with atmospheric sciences. Now with the space programs, we are also participating in international programs and 30-meter telescope project, which is a international project. But I think, I just thought, I will mention this, and I will thank you for all your attention. And again, will remind you that please feel free to come and visit us. This is a view from our Devasthal Observatory. You name any mountain peak, you can come to this Tirtha Sthan and enjoy this Tirtha as well. Thank you for your attention.